And now let's see, if a function is increasing on an interval, what do you know if a function is decreasing? So let's go ahead and have some function. We'll call it g. I made it boring. So on this interval, this is g of x. G of x is increasing. So you should be able to tell me what's going on there. And there's probably a question that'll pop up. Okay, so if g of x is increasing on an interval, that means g prime is positive. If g of x is decreasing, that means g prime is negative. When would a function have a max? What would the derivative... Oh, okay. So we have some sort of graph. I made a differentiable. Let's think about each of these places where we have a max. I feel like I just made ghosts with halos. But anyway, where would the function have a max? What would the derivative be doing there? Well, we just talked about the derivative is positive because the function is increasing. The derivative is negative because the function is decreasing. The derivative is positive and then negative. So the derivative changes positive to negative, right? So the first derivative test generally says that if we have a function, so if, I'm not going to write it super formally, I guess, f prime changes positive to negative, there's a max on f. And if f prime changes negative to positive, there's a min on, not of, on f. There's also discussions of endpoints and things like that, so you should think about what is going on at, say, a left-hand endpoint in order for us to have a min or a max, or a right-hand endpoint in order for us to have a min or max, because those are important things to consider. For each problem, find increasing, decreasing, and extrema. Include all analysis, then sketch a graph. Okay, so I'll help you a little bit. Let's see. Let's go ahead and take a derivative. So y prime is negative x minus 4. I'm going to make a number line. This is a y prime number line. That's going to be 0 when x is negative 4. Prior to that, if I plug in negative 10, for example, we have a positive and then a negative. So I'm just going to say my analysis out loud. So y prime goes from positive to negative, which means that y has a max. Y has max at x equals negative 4. I could plug that negative 4 in and figure out what the y value is and things like that. And then the graph's going to look something like this, where that is when x is negative 4. Same idea. Obviously, for you guys, you need to flesh this out a little bit. I'm giving you kind of bare bones explanation. I'm going to write the derivative here as dr dx so you don't get confused what we're doing. So that's 2/3 7x minus 42 to the negative 1/3. And that might scare you, but don't forget, that's just saying, I'll change colors. That's just saying 2 over 3 times 7x minus 42 to the 1/3. And when is that equal to 0? That's 0 at 6. So that means we have a problem at 6. That doesn't mean the derivative is 0, but that does mean the derivative is undefined. That's a critical point. So this is a dr dx number line. So 6 is going to be a problem. Before 6, so let's plug in 0. Negative 42, the cube root of negative 42 is some negative number, times 3 and 2, that's still negative. Plug in 47 million, so that'll be a positive number. So that means dr dx is going negative to positive, which means we have a min on r. Again, you should have more explanation, but it's going to do something like that. And these 2/3 graphs often look something like this.